What if every choice you've ever made, every path taken or ignored, didn't just vanish into the past but split reality itself into infinite branching timelines? Picture this: somewhere out there, a version of you turned left instead of right, said yes instead of no, or even vanished without a trace. This isn't science fiction. It's the spine-tingling heart of multiverse theory, a concept so vast and bizarre, it redefines everything we thought we knew about existence. From the moment you hit play on this video, you're stepping into a labyrinth of cosmic possibilities where the rules of reality bend and shatter. We're about to unravel 30 shocking secrets hidden within the multiverse, each one more mind-bending than the last. Secrets that'll make you question whether you're truly alone in this universe or any other. Think of the universe as a single page in an endless book, each page telling a different story of what could have been. Scientists call this the many worlds interpretation, where every quantum decision spawns a new reality. But here's where it gets even wilder. Some theories suggest these parallel worlds might not just be echoes of our own. They could be realms with entirely different laws of physics, where time runs backward, gravity doesn't exist, or life takes forms we can't even imagine. And if that doesn't send chills down your spine, consider this. What if some of these universes are closer than we think? What if, right now, you're brushing shoulders with invisible dimensions just a hair's breadth away? This isn't just about theoretical physics scribbled on a chalkboard. It's about the profound, haunting question at the core of our existence. Are we unique, or are we one thread in an infinite tapestry of selves? Over the next journey, we'll dive into evidence that blurs the line between science and the supernatural, from quantum experiments that defy logic to eerie cases of glitches in the matrix that suggest our world might not be as solid as it seems. By the time we're done, you'll never look at reality the same way again. So buckle up, because the multiverse isn't just a theory. It might be the most terrifying, awe-inspiring truth lurking just beyond the edges of your perception. And once you peer behind the curtain, there's no going back. Imagine standing in front of a mirror, but instead of seeing just your reflection, the glass reveals every possible version of yourself, each one shaped by choices you never made. That's the mind-bending reality of the multiverse's first shocking secret. Infinite universes don't just could exist, they must. According to the most cutting-edge physics, our universe isn't a solo act. It's one thread in a tapestry of realities so vast, even the word infinite feels too small. The foundation of this idea comes from quantum mechanics, where particles exist in multiple states at once until observed, like a cosmic game of choose-your-own-adventure. But here's the twist: the many worlds interpretation suggests every possible outcome does happen, just in separate universes. Picture a single moment, say, you flipping a coin. In one reality, it lands heads, in another, tails. But what if you never flipped it at all? That's a third universe. Now scale that up to every decision, every random event since the dawn of time. The math doesn't just hint at parallel worlds, it demands them. Cosmic inflation theory cranks this up to mind-melting levels. When our universe burst into existence during the Big Bang, space itself expanded faster than light. But what if that expansion never stopped? Some physicists argue it didn't. Instead, pockets of space-time pinched off like bubbles in a boiling pot, each becoming its own universe with unique laws of physics. One might have stronger gravity, making stars burn out in seconds. Another could lack dark energy, collapsing back into a cosmic crunch. Now for the jaw-dropper. In this infinite sea of realities, there's a universe where dinosaurs still rule Earth. One where the Roman Empire never fell. Even one where you became an astronaut instead of watching this video. The implications are staggering. Every fictional story, every what if whispered at midnight somewhere, it's real. But the most haunting question isn't whether these universes exist. It's whether we'll ever find proof, or if the multiverse is destined to remain the ultimate cosmic ghost forever just beyond our reach. Here's where the multiverse theory gets personal. Your choices aren't just changing your life, they're rewriting reality itself. According to the many worlds interpretation, every tiny quantum event, every split-second decision, cracks the universe into two like a cosmic fork in the road. Take something as simple as skipping breakfast this morning. In one universe, you grabbed that toast, and maybe the extra energy led you to notice an opportunity you'd otherwise miss. In this one, you didn't, but here's the kicker: both versions of you are equally real, living out their own timelines in parallel dimensions. The famous Schrödinger's cat thought experiment paints this perfectly. In a sealed box, a cat is both alive and dead until you open it, a quantum paradox showing how observation forces reality to pick a side. But the many worlds interpretation flips the script. The cat doesn't settle on one fate. Instead, the universe splits. In one branch, you find a purring cat. In another, a tragic outcome. No paradox, just two equally valid realities spinning off from that single moment. Now apply that to your life. That job offer you turned down, there's a universe where you accepted it, and that version of you is climbing the corporate ladder right now. The stranger you didn't speak to on the bus, somewhere your alternate self married them. Even the thoughts you dismiss like swerving left instead of right on an empty road could have spawned universes where everything changed. The math suggests these splits happen countless times per second, with reality branching like a fractal tree. But what's truly unsettling isn't the endless copies of you, it's the eerie possibility that some of these branching paths might not stay separate forever. Quantum entanglement hints that parallel worlds could briefly overlap, creating echoes of those other lives. Ever felt déjà vu so strong it raised the hairs on your neck? Or dreamed a moment before it happened? Some physicists speculate these could be glitches, fleeting brushes with the versions of reality you almost lived. The chilling truth: you're not just making choices, you're an architect building new universes with every breath. And somewhere out there in the vast cosmic tapestry, another you is pondering this exact idea, wondering if they are the original. Somewhere in the cosmic sprawl of the multiverse, there's a version of you reading these words, but their life might be unrecognizable from yours. The third spine-chilling secret of multiverse theory reveals that your doppelgangers aren't just sci-fi fantasies, they're mathematical certainties. These aren't mere copies with different hairstyles. Some alternate yous live in near-identical worlds, differing by just one tiny choice. Others inhabit realities so alien you wouldn't believe they shared your DNA. Take a mundane moment, say, scrolling through your phone right now. In one universe, your alternate self put it down to answer the door, meeting a stranger who changes their life. In another, they never bought that phone at all, living off-grid in a cabin. Somewhere out there, a version of you speaks fluent Mandarin, or breathes methane on a planet with purple skies, or never existed because their grandparents never met. The spectrum of yous stretches from eerily familiar to utterly incomprehensible. Here's where it gets philosophical. Which one is the real you? The answer might be all or none. Quantum physics suggests each version is equally valid, their consciousness flowing separately like rivers from the same source. That means somewhere, a you who made all the right choices is living your dream life. But also one who made every wrong turn. The unsettling beauty: none of them are more you than the one hearing these words. Consider this thought experiment. Close your eyes and picture your most pivotal crossroads. The college you chose, the confession you held back, the near-miss accident. Now imagine tuning into a cosmic radio, flipping through frequencies where each decision played out differently. One station crackles with laughter as your comedian alter ego kills on stage. Another buzzes with the silence of a monastery where you took vows, the static between stations. Those are the universes where you didn't survive childhood, But the true mind bender isn't just that these versions exist, it's that they might leave traces. Certain quantum models suggest parallel worlds occasionally leak, creating overlaps. Ever met someone and felt an uncanny connection, like you've known them forever? Or had a dream so vivid it lingers for days? Some theorists propose these could be fleeting mergers with other timelines, glimpses of lives you're living elsewhere. So the next time you hesitate at a crossroads, remember, you're not just choosing a path, you're selecting which version of yourself gets to keep walking in this particular universe while countless others spin off into the dark, carrying pieces of what might have been. Time travel isn't just possible in the multiverse, it's downright inevitable. And here's the game-changing twist: with infinite branching timelines, all those messy paradoxes that make physicists cringe, they vanish like smoke. Think about the classic grandfather paradox. What if you went back and accidentally prevented your own birth? In a single universe, that's a logic-shattering nightmare. But in the multiverse, you don't erase history, you create a new one. Take Avengers Endgame. When the heroes hop through time to snatch the Infinity Stones, they're not rewriting their own past. They're spawning fresh timelines where their actions play out differently. That's not just Hollywood magic, it's shockingly close to what physicists like David Deutsch propose. Every time travel event isn't a rewrite, it's a fork in the road. Step back to 1945 and toss a rock through your grandparents' window. Congratulations, you've just split reality. In one universe, your grandparents freak out but still meet at that dance next week. In another, the noise startles them into leaving early, and a different version of you is never born. But your original timeline, untouched. Real-world quantum mechanics hints at this too. Experiments with particles show that observing the past can change its outcome, but only if you accept that every possibility spins off its own universe. It's like a cosmic undo button that doesn't delete the original file, just saves a new version. Even Stephen Hawking flirted with this idea, suggesting time travelers might find themselves in parallel realities rather than their own. So what does this mean for you? Imagine stepping into a time machine tomorrow. You couldn't return to your 2024, you'd arrive in a nearly identical one where your future is still unwritten. And that's the most liberating and terrifying part of multiverse time travel. Every decision, every misstep, every what if becomes a doorway, not a dead end. The multiverse doesn't just allow time travel, it demands it, because somewhere in the infinite fractal of reality, every possible past and future is already happening. You're not breaking the rules of time, you're just playing by the multiverse's wilder ones. Black holes aren't just cosmic vacuum cleaners, they might be the universe's secret backdoors. Picture this, a singularity so dense it doesn't just bend space-time, it punches straight through it. Einstein's equations hinted at this a century ago with the idea of Einstein-Rosen bridges, now known as wormholes. These aren't just sci-fi tunnels, they're mathematical realities where the crushing gravity of a black hole could twist space so violently, it folds like a piece of paper, stitching two distant points together. Think of space-time as a stretched bedsheet. Place a bowling ball in the center, and it creates a deep dip that's a black hole's gravity well. Now imagine pressing down so hard that the sheet tears, but instead of a hole, the edges fuse to another sheet entirely. That's the essence of a wormhole, a shortcut through the cosmic fabric. And here's the kicker: we might already be detecting them. Some physicists speculate that the bizarre behavior of particles near black holes, like quantum entanglement across vast distances, could be whispers of these hidden tunnels. But what's on the other side? One theory suggests black holes don't lead to oblivion, they're birthing canals for new universes. Just as our Big Bang might have been a white hole spewing out matter, your local supermassive black hole could be the Big Bang of another reality. Imagine diving into Sagittarius, a star at the Milky Way's heart, and emerging in a cosmos where light moves slower or time runs backward. The equations allow it. In fact, some models propose that every black hole contains a tiny, budding universe inside its event horizon, meaning our entire existence could be nestled inside another world's black hole. Now for the twist, these gateways might not stay hypothetical forever. Astronomers are hunting for phantom black holes, objects that behave like black holes but lack the telltale radiation, possibly because they're funneling matter somewhere else. And if Hawking radiation is real, the final moments of an evaporating black hole could unveil a flash of another universe's physics at the point of collapse. The terrifying beauty, even if wormholes exist, surviving the trip is another story. Spaghettification being stretched into atomic noodles by tidal forces is just the start. Quantum feedback loops might snap the tunnel shut like a bear trap. Or worse, you could emerge in a universe where the laws of physics turn you into plasma the instant you arrive. But imagine a civilization advanced enough to stabilize these tunnels, weaving a subway system between realities. That's the ultimate promise and peril of black holes. They're not just endpoints, they're cosmic turnstiles waiting for someone or something to swipe the right key. Let's talk about the most unsettling possibility lurking in the multiverse's shadows, a scenario so bizarre it makes black holes seem downright cozy. Picture a single, fully conscious brain spontaneously forming in the void of deep space, complete with fake memories of a life it never lived, no body. No planet, just a lonely, self-aware organ drifting through the cosmic dark. This isn't the plot of a horror movie. It's the Boltzmann brain paradox, a chilling thought experiment that exposes how the multiverse's endless chaos could produce nightmares beyond our wildest imagination. The paradox gets its name from Ludwig Boltzmann, a 19th century physicist who wrestled with the concept of entropy, the universe's slow slide toward disorder. Here's the twist: given enough time, entropy's randomness can also create order by pure accident. Think of shuffling a deck of cards forever. Eventually, you'll get a perfect ordered sequence by sheer luck. Now scale that up to cosmic proportions. In an infinite multiverse where time and space stretch beyond comprehension, the random jostling of particles could must spontaneously assemble a functioning human brain. Not just once, but infinite times over. But why stop at brains? The same principle suggests entire fake universes could blink into existence, complete with phantom stars, imaginary civilizations, and fabricated histories. These Boltzmann universes would last only seconds before dissolving back into chaos, but to the brains inside, that fleeting moment could feel like an eternity, complete with false memories of a past that never was. The real kicker: there's no way to prove you're not one of these cosmic accidents right now. This isn't just philosophical hand-wringing. Quantum fluctuations, tiny, random changes in energy at the subatomic level prove particles can pop into existence from nothing as long as they vanish quickly. Hawking radiation relies on this very phenomenon near black holes. Now imagine a fluctuation so vast it conjures not just a particle but an entire conscious mind. The math doesn't rule it out. In fact, in an infinitely old multiverse, Boltzmann brains should outnumber real minds like grains of sand on a beach. So here's the existential gut punch. If the multiverse is truly eternal and chaotic, the odds might favor you being a Boltzmann hallucination rather than a flesh and blood human. Every memory, every loved one, even the device you're watching this on statistically, it's more likely to be a fleeting illusion spawned by entropy's dice roll than part of a stable universe. The only comfort: if you are a Boltzmann brain, you'll never know. Your fake reality will feel as real as this one does right now until the universe around you unravels like a bad dream. This paradox isn't just a mind game. It's a serious headache for cosmologists because it threatens to undermine everything we think we know about reality. If Boltzmann brains dominate the multiverse, why do we perceive an orderly, consistent cosmos instead of random chaos? Some theories suggest our universe's laws of physics act like cosmic bouncers, keeping reality too stable for Boltzmann flukes to form. Others propose we live in a baby universe with a finite age, cutting off the infinite time needed for these aberrations to arise, but the darkest interpretation. The multiverse might be teeming with these lonely, phantom minds, each one a tragic glitch in the cosmos, convinced it's real until the void swallows its borrowed memories. Next time you stare at the night sky, consider this. Somewhere out there, a brain just like yours might be doing the same, utterly unaware that its stars, its world, its very thoughts are nothing more than entropy's cruel joke. What if the very laws holding your universe together, gravity, light speed, even time itself, were just local bylaws in a vast cosmic city? Somewhere in the multiverse's infinite sprawl, physics textbooks read like works of fantasy. Stars that collapse under their own gravity in seconds, light so sluggish you could outrun it on a bicycle, time flowing backward like a rewound tape. This isn't poetic speculation, it's the staggering prediction of string theory's landscape, where the fundamental rules of reality are more like dice rolls than divine constants. String theory proposes that at the tiniest scales, everything is made of vibrating loops of energy. But here's the catch, these vibrations require extra dimensions, tiny, curled-up spaces beyond our familiar four. The way these dimensions twist and fold determines how particles interact, effectively writing each universe's rulebook. Picture a cosmic piano with 10 to the power of 500 possible tunings. One setting gives us our universe's gentle gravity and stable atoms. Another creates a world where electromagnetism is so weak, matter crumbles like dry sand. Take gravity, our universe's quiet anchor. A slight tweak in its strength would rewrite existence, make it stronger, and stars burn out in millennia instead of billions of years. Weaker, and galaxies never clump together, leaving the cosmos a dark, lonely soup of drifting gas. Then there's light speed, the universe's ultimate speed limit. In a reality where photons crawl, time dilation would turn simple commutes into generational voyages. One misstep in quantum field equations, and atoms might not bond at all, rendering chemistry and life impossible. Yet mind-bendingly, these alternate physics aren't flaws in the multiverse. They're features. The inflationary model suggests that during the Big Bang, quantum fluctuations stretched into cosmic proportions, imprinting different physics onto each newborn universe like a unique birthmark. Some became sterile voids, others birthed bizarre life forms thriving in extreme conditions we can't fathom. A handful, like ours, struck the perfect balance for complexity. This raises a haunting question. Were the laws of physics designed for life, or is life just an accident of our universe's particular settings? The anthropic principle argues we obviously find ourselves in a habitable universe, survivorship bias on a cosmic scale. But buried in string theory's math is an even wilder idea, that somewhere in the multiverse's labyrinth, a civilization might have discovered their physics are just one configuration in an unfathomable array. Imagine their shock upon realizing their constants were cosmic variables all along. The real kicker, we might already be detecting whispers of these alien physics. When astronomers measure dark energy's mysterious push or ponder why gravity is so weak compared to other forces, they could be glimpsing the ragged edges where our universe's rulebook differs from others. Some models even suggest that rare quantum events like particles tunneling through seemingly impossible barriers are brief overlaps with universes where the laws temporarily align. So the next time you drop a cup and watch it shatter on the floor, consider this. Somewhere in a corner of the multiverse where friction works differently, that same cup is bouncing forever. And in another, it never existed at all. The rules you take for granted aren't just written in stone, they're written in sand, shifting with every new universe born from the void. What if our universe isn't just one layer of reality, but a digital onion with countless skins, each simulation nesting inside another. This is the simulation multiverse theory, where the matrix collides with Inception in a dizzying hall of mirrors. Elon Musk famously claimed the odds we're in base reality are 1 in billions, and the math behind his statement is more unsettling than fiction. If advanced civilizations can create conscious simulations, then statistically, simulated minds would vastly outnumber biological ones, making you far more likely to be lines of code than a flesh and blood human. But here's where it gets recursive. If we're living in a simulation, nothing stops our simulators from being simulations themselves, designed by yet another layer of programmers. Think of it like a video game where characters build their own games, an infinite regression of virtual worlds, each unaware of the ones above. Some physicists argue this could explain quantum weirdness, like particles existing in multiple states until observed. Glitches in the matrix may be just rendering delays from an overworked cosmic server. Now add multiverse theory to the mix. If each simulation can spawn its own child simulations, and if physics parameters can be tweaked, suddenly you have an explosion of virtual universes, each running different physics engines. One might run on Newtonian rules like a retro arcade game. Another could permit magic like exploits where energy isn't conserved, the most haunting possibility. Our simulators might not even know they're simulated, trapped in their own existential loop. This isn't just sci-fi noodling. Oxford philosopher Nick Bostrom's simulation argument lays out a trilemma. Either civilizations never reach post-human tech levels unlikely given our trajectory. They choose not to run ancestor simulations ethically questionable, or we're almost certainly living in one. Silicon Valley isn't laughing. Tech leaders are funding research to hack reality for clues, like searching for pixelation in cosmic microwave background radiation or anomalies in quantum behavior. Yet the most profound implication isn't whether we're in a simulation. It's what this says about consciousness itself. If a simulation can host self-aware beings, then reality isn't defined by atoms but by information, meaning the multiverse might not be made of galaxies at all, but of entangled data streams in some unfathomable computer. So the next time your phone glitches or déjà vu hits, ask yourself, was that a bug or a feature in someone else's code? Picture a pot of water just before it boils, countless tiny bubbles forming, merging and popping in a frenzied dance. Now scale that up to cosmic proportions, where each bubble isn't made of soap but is an entire universe inflating at speeds faster than light. This isn't a metaphor, it's the breathtaking premise of eternal inflation theory, and it suggests our cosmos might be just one fizzy bubble in an endless multiverse foam. The idea starts with the Big Bang, but with a twist. Instead of a one-and-done explosion, space itself underwent exponential stretching, doubling in size again and again in fractions of a second. Most cosmologists agree on this inflationary period, but eternal inflation takes it further. Imagine inflation isn't a single event but an endless process, birthing new universes like bubbles in champagne. Regions where inflation slows down become stable universes like ours, while the gaps between them keep expanding eternally, spawning more bubbles ad infinitum. Here's where it gets wild. These bubble universes aren't just floating separately, they can collide. Picture two soap bubbles merging, their surfaces warping as they touch. If our universe bumped into another, the aftermath would be cataclysmic. Astronomers have even scanned the cosmic microwave background, the afterglow of the Big Bang, for eerie bruises that might be scars from such a collision. One candidate, the so-called cold spot, could be a fossilized imprint from a long-ago cosmic fender bender. But the real shocker, these bubbles don't just have different histories, they could have entirely different physics. In eternal inflation, each bubble's properties depend on random quantum fluctuations during its birth. One might have stronger nuclear forces, making stars burn out in a blink. Another could have 10 dimensions instead of our 4, with gravity so weak that planets never form. Somewhere in this froth, there's a bubble where time runs sideways or causality works backward. The implications are staggering. If eternal inflation is true, then the multiverse isn't just a collection of similar worlds. It's a chaotic, infinite zoo of realities, some recognizable, others utterly alien. And here's the kicker, we'll likely never see another bubble directly. The space between them inflates too fast for light to cross, leaving us stranded in our own cosmic bubble like castaways on an island in an unnavigable sea. Yet there's a haunting beauty to this isolation. Everything we know, every galaxy, every atom, every law of physics, might just be local bylaws in our tiny corner of the multiverse. The night sky isn't a window but a mirror, reflecting the walls of our bubble's edge. And somewhere beyond, in the frothy dark, another universe might be sparkling with laws so strange, they'd make our reality look like a glitch in the system. Dark matter, the universe's most stubborn mystery, might not belong to our universe at all. Imagine gravity as a force so relentless, it bleeds through the walls of reality itself, seeping into our cosmos from dimensions just beyond our reach. This isn't some fringe idea. It's a serious hypothesis gaining traction in physics labs. What if dark matter isn't missing matter, but the gravitational shadow of parallel universes pressing against ours? The math behind this is as elegant as it is unnerving. String theory's brain model suggests our universe isn't floating solo in the void. It's a three-dimensional membrane, or brain, drifting like a sheet of paper in a higher dimensional space. Other brains could be hovering mere millimeters away in these extra dimensions, utterly invisible because light and matter are glued to their home brain. But gravity, it's the exception. Unlike other forces, gravity might not be confined to a single brain. It could stretch across dimensions, tugging on us from unseen worlds. Think of it like living in an apartment where you never see your neighbors, but you hear their footsteps through the ceiling. Those vibrations, that's gravity leaking through. In our universe, this leak would manifest as extra gravitational pull with no visible source, exactly what we observe with dark matter. Galaxies rotate faster than they should, and clusters bend light more than visible matter can explain. The culprit might not be invisible particles, but the collective gravity of stars, planets, and black holes in a parallel brain, warping our universe from the shadows. Researchers at CERN and beyond are probing this with experiments that sound like sci-fi. If extra dimensions exist, particle colliders might create microscopic black holes that vanish almost instantly, evidence of gravity, draining into another brain. Other teams are hunting for subtle deviations in gravity's strength at tiny scales, where the influence of nearby brains could poke through. Even cosmic phenomena like the Hubble tension, the puzzling mismatch in the universe's expansion rate, could hint at gravitational contamination from alternate realities. The implications rewrite everything. Dark matter isn't just a placeholder in our equations, it's a cosmic postcard from universes we'll never see. And if gravity truly bridges dimensions, black holes might not be one-way trips. They could be knots where brains touch, fraying the fabric between worlds. Picture two sheets of paper pressed together, a pinprick hole connecting them. That's the terrifying beauty of this theory. The very force keeping your feet on the ground might be the multiverse's way of whispering, "You're not alone." But here's the twist: if dark matter is gravity from other brains, those universes could be radically different from ours. Their physics might not even allow atoms to form, making them sterile voids dominated by pure gravity. Yet their invisible weight would sculpt our cosmos, bending galaxies into spirals and weaving the large-scale structure of the universe. We'd be living in a shadow play, our reality shaped by ghosts we can't touch, see, or prove exist. Until perhaps the day we finally detect gravity's echo and realize it's not an echo at all, it's a handshake from the universe next door. What if the truth about UFOs isn't hidden in distant star systems, but lurking just beyond the edges of our dimension? For decades, the search for extraterrestrials has fixated on crossing vast stretches of space, yet the Fermi paradox looms large. If the universe is teeming with life, where is everybody? The answer might be chillingly simple. They're not out there at all. They're right here, just out of phase. Declassified government reports describe UFOs performing maneuvers that defy known physics: instant acceleration, abrupt 90-degree turns, vanishing without a trace. Fighter pilots report objects diving into the ocean without splash or entering airspace without appearing on radar. These aren't just technological marvels. They're behaviors that align eerily with theoretical models of interdimensional travel. Imagine a sheet of paper representing our reality. A being from a higher dimension could fold that paper, moving between points instantly. No rockets, no light years, just a shortcut through the multiverse's hidden layers. The implications rewrite the UFO mystery. If visitors are slipping between dimensions, their craft wouldn't need propulsion as we understand it. They'd ride the wrinkles of space-time itself, appearing and disappearing like mirages. This could explain why UFOs often materialize near nuclear facilities or fault lines, areas where the fabric of reality might be unusually thin, creating temporary portals. Even the infamous tic-tac UFOs captured on military footage exhibit movement patterns resembling quantum tunneling, where particles vanish and reappear across barriers. Now consider the most provocative twist. These aliens might not be aliens at all. They could be alternate versions of us, descendants of a parallel Earth where evolution or technology took a different path. Picture a civilization that cracked the code of dimensional travel 1,000 years ago, now observing their genetic cousins like anthropologists watching a primitive tribe. It would explain why many UFO encounters feature humanoid figures and why their technology seems both impossibly advanced and strangely intuitive, like a future we almost recognize. The US government's recent admissions about unidentified aerial phenomena take on new weight in this light. When officials cite objects demonstrating capabilities beyond any known human technology, they might unknowingly be describing artifacts from a reality where physics operates differently. Even historical accounts, from medieval paintings of sky disks to Native American legends of star people, could be fragmented memories of cross-dimensional contact. The haunting question isn't whether we're alone in the universe. It's whether we've been missing the true nature of our visitors all along, not because they're too far away, but because they're closer than we ever dared imagine, separated not by distance but by the thinnest veil of reality. And if they can cross that barrier at will, we might not be the ones in control of when or if first contact finally happens. What if death isn't the end, just a door you never walk through? The 12th spine-arching secret of the multiverse forces us to stare into the abyss of quantum immortality, a theory so unsettling, it redefines what it means to cease existing. Picture this: every time you brush against mortality, a near-miss accident, a terminal diagnosis, even old age, your consciousness doesn't flicker out. It simply shifts. Like a radio tuning to the next clearest station, you're shunted into a timeline where you survived, while another version of reality mourns your loss. This isn't mystical speculation, it's a brutal consequence of the many worlds interpretation of quantum mechanics. Every moment, reality branches based on probabilities. Roll a die, and there's a universe where it lands on 1, 2, 3, all the way up to 6. Now apply that to survival. Step into traffic and narrowly escape a speeding car. In another timeline, you didn't. But here's the kicker: your subjective experience can only continue in realities where you're alive. From your perspective, you'll always find yourself in the branch where the coin flip spared you, no matter how improbable the escape. The thought experiment gets darker. Imagine a modified version of Schrödinger's cat where, instead of a feline, you sit in the box with a gun rigged to a quantum trigger. In half the universes, the gun fires. In the other half, it jams. but you'll never experience the fatal outcome, only the ones where, by sheer luck, you walk away unharmed. Repeat this 1,000 times, and statistically, there must be a universe where you survive against all odds. That's quantum immortality in action. Consciousness acting like a cosmic hitchhiker, always jumping to the timeline where it persists. Critics argue this reduces existence to a morbid lottery where death is an illusion for the observer. But supporters point to eerie real-world parallels: people surviving plane crashes with improbable explanations, or terminal patients who defy medical expectations. Even more chilling are accounts from those who swear they should have died in accidents, only to walk away with memories of events that, by all laws of physics, shouldn't have left them breathing. The philosophical weight is crushing. If quantum immortality holds, does anyone ever truly die from their own perspective? Or does each mind inevitably find itself in the universe where it endures, watching others perish while it lingers first for decades, then centuries, until reality itself becomes a hall of mirrors where you're the last witness? The theory suggests a horrifying corollary: you might already be immortal, not in the poetic sense, but in the literal, unending slog of a consciousness that can't experience its own end. Yet there's a haunting beauty here too. Quantum immortality doesn't promise invincibility, just the absence of finality. Every scar, every close call becomes proof that somewhere your other selves weren't so lucky. And when your body finally fails in all possible timelines, maybe then, and only then, the curtain falls. Until that day, the multiverse keeps dealing you a hand where, against all odds, you're always the one who walks away. Ever found yourself locked in an argument over whether that cornucopia was always part of the Fruit of the Loom logo? Or how about swearing on your life that the Monopoly man wore a monocle only to Google it and find zero evidence he ever did? Welcome to the unsettling world of the Mandela effect, where collective false memories aren't just quirks of the mind, they might be whispers from other timelines. This phenomenon gets its name from Nelson Mandela himself. Thousands of people vividly recall him dying in prison during the 1980s, complete with news footage of his funeral. But history tells a different story. Mandela walked free in 1990 and became South Africa's president. So why do so many share this exact same fabricated memory? One theory slices deeper than faulty neurons. What if these discrepancies aren't mistakes at all, but residual echoes from parallel universes where events did unfold differently? Take the Berenstain Bears. A legion of fans would bet their childhood books spelled it Berenstein with an E, except it never did. The creators confirm it was always Berenstain. Yet the misremembering is too precise, too widespread to dismiss as simple confusion. Could this be a glitch where two timelines briefly overlapped, one where the bear's name had that silent E and ours where it never existed? Quantum physics allows for such overlaps. When particles entangle across dimensions, information can bleed through. If subatomic particles can do it, why not memories? The real spine chiller: these false memories often come with visceral certainty. People don't just think they recall Darth Vader saying, "Luke, I am your father." He actually says, "No, I am your father." They hear it in James Earl Jones' voice, can picture the scene. That specificity mirrors how we encode real experiences. If memories were just random errors, they'd be fuzzy and inconsistent. But Mandela effects are startlingly uniform, like thousands of people independently downloading the same corrupted file. Here's where it gets weirder. Some researchers suggest these overlaps might cluster around emotionally charged events or iconic pop culture, precisely the moments our brains anchor to most tightly. Think of reality as a woven tapestry. At points of high cultural tension like Mandela's imprisonment or childhood media imprinted on millions, the fabric might stretch thin, allowing threads from other universes to snag through. But before you dismiss this as sci-fi, consider the science. The many worlds interpretation insists every quantum possibility spawns a new universe. If so, there's a timeline where every Mandela effect is objectively true. The real question isn't whether these alternate realities exist, it's whether the walls between them are as solid as we think. Every time you and a friend argue over how it really was, you might be standing at the edge of a cosmic seam, tugging at threads from a world that's almost but not quite your own. So the next time someone corrects your memory, don't just shrug, pause, listen to that nagging certainty in your gut, because somewhere out there in the multiverse's infinite kaleidoscope, the version of you who's absolutely right is standing just as baffled, wondering why everyone else forgot the truth. Scientists have been scratching their heads over a cosmic mystery for decades. Why does the math of the universe's energy budget refuse to add up? When you tally up all the matter, radiation, and known forces, there's a glaring shortfall, as if reality itself is missing a chunk of its paycheck. But what if that missing energy isn't lost at all? What if it's been leaking into our universe from dimensions we can't see? This isn't just a hunch, it's a serious hypothesis tied to one of physics' most baffling discoveries, dark energy. Picture the vacuum of space. Far from being empty, it's a seething quantum foam where particles pop in and out of existence constantly. This activity generates what's called vacuum energy, a theoretical background hum that, according to calculations, should be unimaginably strong. Yet when we measure it, the energy is shockingly weak, about 120 orders of magnitude fainter than predicted. It's like expecting a roaring jet engine and hearing a barely audible whisper instead. Here's where parallel universes step in. Some theories suggest this discrepancy happens because vacuum energy isn't confined to our universe alone. It's shared across the multiverse like a cosmic utility bill. Imagine blowing up a balloon with tiny holes poked in it. No matter how hard you inflate it, some air escapes, keeping the pressure lower than expected. Our universe might be that balloon, with dark energy bleeding into neighboring dimensions through hidden channels in spacetime. Even more intriguing is the possibility that dark energy itself, the mysterious force accelerating the universe's expansion, might be the gravitational tug of adjacent realities. Think of two boats floating side by side on a calm lake. Even if they never touch, their wakes push and pull each other subtly. If other universes are floating near ours in higher dimensional space, their gravity could stretch our cosmos from the outside, creating the illusion of an unseen force within. The math gets wilder. In certain string theory models, universes with different vacuum energies are constantly budding off one another like branches on a tree. Most would collapse instantly or rip themselves apart, but a rare few, like ours, strike the delicate balance needed for stars and life. This anthropic selection could explain why we measure such an oddly small vacuum energy. We literally couldn't exist in the versions where it's stronger. The real kicker, we might already be seeing traces of this multiversal energy exchange. Some astrophysicists argue that anomalies in the cosmic microwave background, the afterglow of the Big Bang, show faint bruises where our universe once brushed against another. Others speculate that dark energy's strength isn't constant but fluctuates over time, as if we're feeling the ebb and flow of unseen cosmic tides. So the next time you hear that the universe's energy is missing, consider this: it might not be gone, just borrowed by infinite other realities, each quietly siphoning off their share of the multiverse's vast, invisible reservoir. And if we ever find the proof, it won't just rewrite physics textbooks, it'll reveal that our universe has been holding hands with strangers all along. We think of time as an arrow always flying forward, never backward. But hidden in the math of the multiverse is a shocking truth. Time might not even have a preferred direction in other realities. Picture a universe where rivers flow uphill, where shattered glasses leap back onto tables, and where people grow younger with each passing day. This isn't just fantasy, it's a legitimate possibility under the laws of physics. Take entropy, the universe's natural tendency toward disorder. In our world, spilled milk never unspills itself, and scrambled eggs don't unscramble because entropy only increases over time. But flip that script and suddenly you've got a reality where time runs in reverse, where chaos sorts itself into order like a movie played backward. Some universes might even exist in perfect balance, with entropy locked in an endless loop. Imagine a cosmic Groundhog Day where the same events repeat eternally without memory. Even more bizarre are universes where time isn't linear at all. Think of Doctor Who's tangled timelines where cause and effect twist like a Möbius strip. In such realities, you could meet your future self before making the choices that lead you there, creating paradoxes so deep they'd make a TARDIS circuit smoke. Some quantum models suggest these loops aren't just fiction. They might be woven into the fabric of certain dimensions, where the future influences the past as much as the past shapes the future. Now consider this: if time flows differently elsewhere, how would consciousness even work in those worlds? Would beings in a reverse time universe remember tomorrow while forgetting yesterday? Would a looped reality trap minds in endless déjà vu? The very concept of now becomes meaningless when before and after stop following rules. Our universe's arrow of time might be nothing more than a local quirk, a cosmic accident of entropy that happened to favor one direction. Step beyond our bubble, and you might find realities where time spirals, stutters, or stands still entirely. After all, if the multiverse truly contains every possible configuration of physics, then somewhere out there, a clock is ticking backward right now. And another isn't ticking at all. What if you could peek behind the curtain of reality, not with telescopes or microscopes, but with a single beam of light split in two? The double-slit experiment isn't just a party trick of quantum physics, it's a window into the multiverse, and its results are so bizarre, they've left scientists questioning the very nature of existence. Here's how it works: fire particles like electrons or photons at a barrier with two narrow slits. If particles behaved like tiny bullets, you'd expect two neat piles on the detector screen behind. But that's not what happens. Instead, you get an interference pattern. Stripes of light and dark, as if each particle spread out like a wave, passed through both slits at once and interfered with itself on the other side. This already shatters classical logic, but the real shock comes when you try to catch the particles in the act. Place a detector to observe which slit each particle goes through, and something incredible happens. The interference pattern vanishes. The particles suddenly behave like well-behaved bullets again, as if they knew they were being watched. It's not just spooky, it suggests that at the quantum level, reality exists in multiple states until observation forces it to choose. The many worlds interpretation takes this further. The particle doesn't collapse into one path. Instead, the universe splits, one where it went left, another where it went right. Both outcomes are real, just in parallel dimensions. Now, crank the weirdness up another notch with the delayed choice quantum eraser. In this mind-bending twist, scientists can erase information about which slit a particle took after it's already hit the detector. The result, the interference pattern magically reappears, as if the universe retroactively changes its mind about whether the particle was a wave or a particle. This isn't just time travel logic. It's evidence that quantum systems might be entangled across multiple timelines, where past, present, and future aren't fixed but fluid. Imagine two detectives investigating a crime scene. One leaves fingerprints everywhere, altering the evidence like an observer in the double-slit experiment. The second detective, however, works in reverse, removing fingerprints after the fact, restoring the scene to its original state, the eraser experiment. In both cases, reality isn't a static thing. It's a dance of possibilities, shaped by observation and time in ways we're only beginning to grasp. The chilling implication. These experiments might not just be detecting parallel worlds, they could be creating them. Every time a quantum system branches, it doesn't just reflect the multiverse, it adds to it, spinning off new realities like threads from a cosmic loom. And if that's true, then right now, in some hidden corner of the quantum foam, another version of you is watching this same experiment unfold, with results just slightly different enough to rewrite their understanding of everything. Across the infinite sprawl of the multiverse, a chilling possibility emerges that the gods we've worshipped, feared, and sought throughout history might not be supernatural at all. They could be beings from universes where physics permits technologies so advanced they'd seem like magic to us. Arthur C. Clarke famously said, "Any sufficiently advanced technology is indistinguishable from divinity." And in the multiverse, this isn't poetic speculation, it's a spine-tingling likelihood. Imagine a civilization just a few thousand years ahead of us. Now stretch that gap to millions or billions. In a reality where quantum computing is as rudimentary as stone tools are to us, beings could manipulate matter at the atomic level with a thought, rewrite genetic code in real time, or even engineer entire stars. To less advanced observers, these feats would defy all logic, miracles indistinguishable from divine intervention. Lightning summoned on command, that's just directed energy. Resurrection of the dead, a well-timed application of nanotech reconstruction. Even prophecies could be the result of hyper-advanced simulation models predicting futures with near-perfect accuracy. Consider our own history. When European explorers arrived in the Americas with firearms and metal armor, indigenous peoples initially interpreted them as gods or spirits, not because they were, but because their technology existed outside local understanding. Now scale that concept to the multiverse, a being capable of folding space-time to appear anywhere instantly, or harnessing dark energy to reshape galaxies wouldn't just seem powerful. They'd fit every definition of a deity we've ever conceived. Religions across cultures describe gods descending from the heavens in fiery chariots, wielding weapons that shake mountains. What if these weren't metaphors, but fragmented memories of cross-dimensional contact? The Hindu concept of the Vimana flying palaces said to carry gods bears uncanny resemblance to modern UFO accounts. The biblical pillar of fire that guided Moses through the desert, could it have been a plasma-based navigation beacon? Even the idea of omnipresence takes on new meaning if a civilization mastered quantum entanglement, allowing them to be in multiple places simultaneously. The unsettling implication isn't just that gods might exist, but that they could be utterly unaware of our worship. A scientist in a lab coat doesn't consider themselves a deity to the bacteria under their microscope. Similarly, a hyper-advanced being tinkering with cosmic forces might not recognize their accidental role as a creator or destroyer in fledgling worlds. Their miracles could be routine experiments, their wrath simply the side effects of technologies they barely notice. Yet the darkest twist lies in universes where such beings do interact intentionally. Picture a reality where a civilization, having conquered mortality and harnessed the energy of stars, grows bored. What's left but to play at being gods? They might seed life across dimensions like gardeners, observing which worlds bloom or wither, or worse, experiment with civilizations, testing limits through engineered plagues, artificial famines, or staged revelations. The terrifying truth, our universe could be one of their petri dishes, our prayers nothing more than data points in an unfathomable project. But here's the humbling counterpoint. Somewhere in the multiverse, we might be the gods. In a reality where life evolved faster or physics made technology easier to master, humanity could be the advanced civilization peering into lesser universes, inspiring myths of glowing giants or sky spirits. The divine isn't a fixed point, it's a mirror, reflecting whoever stands on the higher ground of understanding. And in the infinite multiverse, that ground shifts with every new dimension. If every choice you make spawns a new universe, then who or what is really steering the ship? This is the paradox at the heart of free will in the multiverse. On one hand, infinite versions of you suggest infinite possibilities. On the other, if every conceivable outcome already exists somewhere, does that mean your choices are just illusions, pre-scripted moments in an endless cosmic play? Let's break this down with a simple scenario. You're standing at a vending machine torn between soda and juice. You press the button for soda, and in that instant, the universe splits. One branch where you chose juice, another where you stuck with soda. But here's the rub. If both outcomes were inevitable, did you ever truly have a say? Determinists argue that your decision was just the sum of prior causes. Your thirst, past preferences, even the lighting on the buttons, all traceable back to the Big Bang. In their view, free will is a comforting myth, and the multiverse simply reveals the clockwork behind the curtain. Yet quantum mechanics throws a wrench into that machinery. At the subatomic level, particles don't follow predictable paths. They exist as probabilities until observed. This inherent randomness suggests the universe isn't a predetermined puzzle but a dice roll at every turn. Apply that to your vending machine dilemma. Maybe your choice wasn't fated at all. Maybe the quantum noise in your brain tipped the scales unpredictably, making your soda selection a genuine act of spontaneity in an otherwise branching cosmos. The many worlds interpretation straddles both ideas. It says every quantum possibility plays out somewhere, but your conscious experience locks onto one path like a train switching tracks. You feel the weight of choice because your awareness can only ride one timeline at a time. In this light, free will isn't about controlling every outcome. It's about which version of events you get to live through. But the most unsettling question isn't whether you have free will. It's whether the multiverse turns life into a cosmic choose-your-own-adventure book where every ending already exists. Are you the author or just a reader flipping pages? The answer might depend on where you stand in the age-old fight between randomness and destiny, a fight raging not just in philosophy classrooms but in every atom of your being. Here's the twist. If free will is real, then somewhere in the multiverse, a version of you is reading these words and concluding the opposite. And that's the beauty and the terror of infinite possibilities. No matter what you believe, there's always another you out there, equally convinced they're right. The numbers don't add up, not even close. The universe's fundamental constants are so precisely tuned for life, it's like winning the lottery 1 trillion times in a row. Gravity could have been slightly stronger, snuffing out stars before planets formed. The strong nuclear force might have been weaker, preventing atoms from sticking together. Even the tiniest tweak to the cosmological constant would have left reality as an empty void or a collapsed lump. The odds of all these dials landing in the perfect positions by chance. So infinitesimal, it's statistically easier to believe in magic. Yet here we are, breathing, thinking, questioning, living proof of a cosmic fluke that shouldn't exist. This is the fine-tuning problem, and it haunts physicists like a ghost in the equations. Take gravity, for example. Increase its strength by just 1 part in 10,000 billion, and stars would burn out millions of times faster, leaving no time for life to evolve. Adjust the electromagnetic force by a hair, and carbon atoms, the backbone of biology, might never form in stellar furnaces. Even the expansion rate of the universe sits on a knife's edge. A fraction faster after the Big Bang, and matter would have scattered too thin to clump into galaxies. A fraction slower, and everything would have collapsed back into a singularity before the first hydrogen atom could spark. The multiverse offers a chilling solution to this riddle. If every possible combination of constants exists across infinite realities, then of course one universe would randomly hit the jackpot. We're not witnessing a miracle, we're just the lucky winners in a cosmic casino where every slot machine spins eternally. Think of it like this: if you shuffle a deck of cards forever, eventually you'll deal yourself a perfect royal flush. Now imagine that deck has more cards than atoms in the observable universe, and you've played the game an infinite number of times. Suddenly, our life-friendly cosmos stops looking like a statistical anomaly and starts looking inevitable. But here's where it gets even stranger. Some universes might not just have different constants, they could operate on entirely different rules. Imagine a reality where pi isn't 3.14 but a variable that changes with location. Or where the speed of light isn't a limit but a suggestion. In such a multiverse, our existence isn't just rare, it's a single flickering candle in a vast, chaotic storm of impossibilities. The real question isn't why our universe is fine-tuned. It's whether we'll ever find proof of the other, failed universes where the numbers didn't line up. Some theorists hunt for echoes of cosmic collisions in the microwave background, bruises from bubbles where physics briefly aligned differently. Others look for mathematical fingerprints in the behavior of black holes, which might act as windows into adjacent realities. And then there's the existential twist. If the multiverse does explain fine-tuning, then somewhere out there, a version of you is pondering this exact idea in a universe that shouldn't exist either. What if our three-dimensional world, with all its towering mountains, swirling galaxies, and the very screen you're staring at is just an elaborate illusion? A cosmic mirage projected from a flat, two-dimensional surface like a movie playing on some unimaginable celestial screen. This is the essence of the holographic principle, a theory so radical, it suggests reality as we know it might be nothing more than an incredibly convincing hologram. Now stretch that idea across the multiverse, and suddenly, every parallel reality could be interlaced like pages in a book where each page is both its own universe and part of a grander pattern. The holographic principle emerged from an unexpected place, the study of black holes. When physicists calculated how information behaves at a black hole's event horizon, they hit a paradox. The laws of quantum mechanics insist information can't be destroyed, yet black holes seemingly swallow it whole. The solution: maybe the information isn't lost, it's smeared across the surface of the event horizon like data encoded on a DVD. Our three-dimensional reality, then, would be the movie that data produces when played back. Think of it like this. When you watch a 3D film, the glasses trick your brain into seeing depth, but the actual image on the screen is flat. The holographic universe suggests we're all wearing cosmic 3D glasses, interpreting a 2D code as the rich, textured world around us. Now apply this to the multiverse. If our universe is a holographic projection, why couldn't others be too? Picture an endless stack of DVDs, each containing a slightly different film. Some where Earth never formed, others where gravity works backwards. These holographic universes wouldn't float separately like isolated bubbles. They'd be layered, their information entangled at the edges where projections overlap. In this model, crossing between realities wouldn't require wormholes or spaceships. It'd be a matter of decoding the source data, like switching channels on a TV where each station is its own self-contained cosmos. Here's where it gets truly mind-bending. If the multiverse is a network of holograms, then the boundaries between universes might be far more permeable than we think. Quantum entanglement, where particles instantly influence each other across vast distances, could be evidence of this deeper connection. When two particles become entangled, perhaps it's not spooky action at a distance. It's those particles being shadows of the same ink on the 2D surface. Their fates linked because at the fundamental level, they're literally the same piece of code. The most unsettling implication: if the holographic multiverse is real, then free will, time, even the concept of you might be emergent properties of something far simpler. Your choices, your memories, the very sensation of being alive, all could be the result of a vast cosmic projector stitching together a convincing illusion of continuity. And somewhere in the static between projections, another version of you might be reaching through the noise, wondering if they're the one casting the shadow. Or if they're the shadow itself. The moment you open your eyes each morning, you're not just waking up to reality, you might be actively creating it. At the heart of quantum mechanics lies a truth so unsettling, it rewrites the role of consciousness in the cosmos. The observer shapes the observed. This isn't philosophy, it's cold, hard physics. When scientists measure particles in the lab, those particles don't behave like tiny billiard balls following predictable paths. They exist as clouds of probability, mathematical ghosts hovering between all possible states until someone looks. The act of observation, of measurement, forces the system to choose a single outcome. But here's the mind-blowing twist. The many worlds interpretation suggests it doesn't choose at all. Instead, every possible outcome blossoms into its own reality, with conscious observers branching along with them. This idea, called the participatory anthropic principle, flips the traditional view of reality on its head. We're not passive passengers in a predetermined universe. We're co-creators, our awareness weaving one thread of existence out of infinite possibilities. Think of it like a cosmic choose-your-own-adventure book where the story doesn't exist until you read it, and every time you turn the page, the multiverse spawns new volumes for every path you didn't take. Your consciousness isn't just along for the ride, it's the engine making the whole thing go. The implications ripple through everything. Take the famous Schrödinger's cat paradox. In the classic thought experiment, the cat is both alive and dead until observed. But in a multiverse framework, there's no paradox, just two equally real universes splitting at the moment of observation. One where you open the box to a purring feline, another where you're met with silence. Your awareness doesn't collapse the possibilities, it becomes entangled with them, ensuring you only experience one outcome while countless other yous experience the rest. Now scale this up to everyday life. That decision to check your phone right now, in one universe you did and maybe saw a message that changes your day. In another you didn't, and the day unfolds differently. The eerie beauty is that both versions are equally real, you're just only aware of one. Some interpretations even suggest that consciousness isn't merely reacting to reality but actively structuring it, like a sculptor pulling shapes from quantum foam. The most haunting question isn't whether consciousness shapes reality, it's how deep the rabbit hole goes. If our observations create branches, could focused intention bend the odds? Some quantum experiments hint at this, showing that expectation can subtly influence outcomes at microscopic scales. It's as if the universe isn't just a machine, it's a conversation with consciousness whispering into the void and the void whispering back. And here's the kicker, if consciousness is this powerful, what does that say about the nature of you? Are you a single observer or a fractal mind spread across infinity, each instance convinced it's the original? The answer might be both and neither. In the multiverse, you're not just a player in the game of reality, you're the rulebook, the dice, and every possible role all at once. At the farthest edges of the multiverse, where infinite realities dissolve into the unknown, lies a question so vast it bends the mind. What, if anything, exists beyond everything? We've traced the branching paths of parallel worlds, glimpsed alternate physics, even entertained the idea of nested simulations, but all these theories still sit within a container. And that container must have an outside. Or does it? Some models suggest the multiverse floats in a sea of pure, unfiltered nothingness, not empty space but true void where the concepts of space and time cease to have meaning. Imagine a painter's canvas so vast it holds every possible painting, and beyond its edges, no canvas at all, no light, no darkness, no rules to define them. This isn't just emptiness, it's the absence of potential itself. Yet even this nothingness might not be the end. Theoretical physicists like Max Tegmark propose that beyond the observable multiverse could lurk higher dimensions, not the tiny, curled-up ones of string theory, but vast, unimaginable directions where entire multiverses move like specks of dust in a cosmic wind. Then there's the meta-universe hypothesis, the idea that our multiverse is just one layer in an infinite stack. Picture a Russian nesting doll where each doll contains countless others, and the doll you're holding is itself nestled in a larger hand. In this model, what we call the multiverse might be a single bubble in a froth of meta-realities. each operating under deeper, stranger laws. Some could be so alien that their fundamental building blocks aren't matter or energy, but concepts beyond our comprehension, universes built from pure mathematics or emotions, or even abstract notions like regret or symmetry. The wildest possibility that the multiverse has no edge at all, not because it's boundless, but because the question itself is meaningless. Just as a fish can't conceive of outside the ocean, our brains might be wired only to perceive reality in terms of containment. The true answer could be something we're neurologically incapable of grasping, locked behind the evolutionary firewall of human cognition. Yet here's the haunting thought that ties it all together. If something does exist beyond the multiverse, it might already be shaping us. Like shadows on a cave wall, the forces outside our cosmic bubble could cast influences we mistake for natural laws. Dark energy's mysterious push, the quantum foam's chaos, even the arrow of time. Each could be fingerprints of something vast and unseen, pressing in from the other side of existence. So when you gaze at the night sky, remember, you're not just looking at stars, you're peering through a keyhole, catching fractured glimpses of a doorway with no walls, no lock, and no certainty of what lies on the other side. Earth had a 1 in 10 chance of never making it past infancy, 4.5 billion years ago, as our planet was still cooling from its violent birth. A Mars-sized object named Theia was hurtling toward us on a collision course. The impact was so catastrophic, it vaporized entire oceans and turned Earth's surface into a molten hellscape. Out of that cosmic wreckage, the moon was born, and somehow, against all odds, life clung on. But here's the stomach-churning truth. In countless other universes, Theia's aim was just a fraction different. In those timelines, the impact was too weak to form the moon, leaving Earth spinning wildly on its axis with chaotic seasons that snuffed out life before it began, or too strong, shattering our planet into a second asteroid belt. This isn't speculation, it's statistical inevitability in a multiverse where every possible collision plays out, and the near misses didn't stop with Earth's infancy. 66 million years ago, the dinosaur-killing asteroid missed by cosmic inches. Simulations show that if it had arrived 30 minutes later, it would have plunged into deep ocean, dispersing its energy harmlessly. No mass extinction, no vacuum for mammals to rise, no you. Yet in another branch of the multiverse, that's exactly what happened, a world where lizards still rule, and humans remain undiscovered twitches in the DNA of tiny, shrew-like creatures. Even in our own timeline, the dice have rolled terrifyingly close to doom. 1983, the height of the Cold War, Soviet satellites detected 5 American missiles streaking toward the USSR. Protocol demanded immediate nuclear retaliation, but one officer, Stanislav Petrov, trusted a gut feeling that it was a false alarm. He was right, a rare sunbeam had tricked the system. In another universe, maybe Petrov hesitated, maybe the orders went through, maybe right now, that Earth is a radioactive wasteland where the few survivors envy the dead. The most chilling evidence we're in a lucky timeline, the Fermi paradox's grim solution. If intelligent life is common, why haven't we heard from anyone? Maybe because most civilizations hit their own version of Theia or Petrov's moment and failed. The multiverse isn't just a place of infinite possibilities. It's a graveyard of failed Earths, a hall of mirrors where we're the rare reflection still standing. So the next time you complain about a bad day, remember, statistically, you shouldn't even exist. Every breath you take is a defiance of cosmic probability, a middle finger to the infinite versions of Earth that didn't make it. The question isn't why our world has problems, it's how anything so fragile survived this long at all. Numbers don't just describe reality, they might be reality. Forget about parallel worlds spawned by quantum choices or bubble universes with different physics. What if existence itself is nothing more than mathematical structures playing out in an infinite symphony of logic? This is the radical heart of Max Tegmark's mathematical multiverse, a theory so extreme, it suggests every possible equation, every geometric shape, every conceivable numerical relationship isn't just an abstraction, but a literal universe waiting to be explored. Think of pi, the familiar 3.14 endless digits we use to calculate circles. In our universe, it's a constant woven into everything from DNA spirals to planetary orbits. But Tegmark's framework insists pi doesn't have to be this value. In a mathematical multiverse, there are realities where pi equals 4, where triangles have 4 sides, or where parallel lines meet at a dozen different points. These aren't just intellectual exercises, they're alternate cosmic rulebooks, each with their own consequences. A universe where pi is 4 would warp circles into strange, squashed shapes, altering everything from atomic orbits to the very fabric of spacetime. Stars might not burn, gravity could repel instead of attract, and life, if it existed at all, would look nothing like us, the terrifying beauty of this idea. Math isn't invented by humans, it's discovered. The Fibonacci sequence appears in sunflower seeds millennia before humans named it. The golden ratio echoes in galaxies far older than our telescopes. Tegmark argues this isn't coincidence. Mathematical truths exist independently of minds to perceive them, meaning universes built from those truths do too. Imagine a library containing every possible book. Most are gibberish, but some tell coherent stories. The mathematical multiverse is like that, an infinite archive where every coherent equation writes itself into existence as a physical reality. Critics dismiss this as Pythagorean mysticism dressed in equations, but the evidence is stranger than they admit. Quantum physics already describes particles as probability waves, pure math manifesting as matter. Black holes reveal information encoded on their surfaces like cosmic barcodes, hinting that our 3D world might be a projection of 2D data. Even the language of physics relies on deep mathematical symmetries no one can explain. Why should the universe obey math unless it is math? Now consider the existential twist. If every mathematical structure is real, then horrors beyond imagination exist somewhere in the multiverse. A reality where entropy decreases could see corpses reassembling in graves. A universe with no conservation laws might have stars appearing and vanishing like fireflies. And somewhere in a realm of fractal dimensions, a version of you is solving equations that literally rewrite their own existence. The ultimate question isn't whether math creates worlds, it's whether we'll ever find traces of the others. Some theorists hunt for anomalies in the cosmic microwave background, scars from collisions with universes where math took different forms. Others probe quantum gravity for whispers of higher dimensional geometries. But the true test might be inside us. If consciousness itself is just information processing a kind of living math, then peering inward could be the first step toward mapping the infinite equations we're made of. So the next time you solve for X, remember, you might not just be doing homework, you could be eavesdropping on another universe's blueprint, one where X equals realities we can't begin to fathom. Long before quantum physics and string theory, ancient texts were already wrestling with the idea that our universe might be just one note in a cosmic symphony. Hindu cosmology describes a breathtaking vision of reality where universes breathe in and out like living things, expanding, collapsing, and being reborn in endless cycles called kalpas. Each kalpa lasts 4.32 billion years, a number shockingly close to modern estimates of Earth's age. Within these vast cycles exist countless lokas, realms or planes of existence, some resembling parallel worlds where different physical and spiritual laws apply. The Bhagavata Purana even describes a cosmic egg containing innumerable universes, each with its own Brahma, Vishnu, and Shiva governing separate realities. This isn't just metaphor. When physicists talk about eternal inflation spawning bubble universes, they're describing a process that mirrors these ancient texts with eerie precision. Buddhism takes it further with its concept of the Trichiliocosm, a universe system of 3,000 worlds, each with its own version of reality. Some realms are hellish, others heavenly, and human existence is just one possibility among infinite variations. Modern cosmology echoes this with the Level 2 multiverse, where different regions of space may have fundamentally altered physics. The Theravada texts speak of 31 planes of existence, from dense material worlds to formless realms beyond time, ideas that resonate with theories about dimensions folded beyond perception. When monks meditate on emptiness, they're exploring a truth physicists chase in equations. That solid reality might be the illusion, and the true nature of existence is vast, interconnected potential. Christianity's many mansions from John 14:2 often get overlooked in multiverse discussions, but the original Greek monai suggests dwelling places or way stations rather than literal houses. Early Gnostic texts envisioned a pleroma, a fullness containing infinite eons, divine realms with their own laws and beings. This aligns startlingly with the string theory landscape, where 10 to the 500 possible vacuum states could each birth a unique universe. Even the Kabbalistic concept of tzimtzum, God's self-withdrawal to make space for creation, parallels inflationary cosmology's idea that space-time expanded into a void. The recurring theme across faiths, that existence is vaster than a single universe and consciousness might transcend any one reality. Hindu rishis spoke of yogis accessing parallel lokas through meditation, just as physicists like Andre Lind suggest consciousness could be a fundamental feature of the multiverse. Whether through prayer or particle colliders, humanity keeps arriving at the same awe-struck conclusion. We're likely just one thread in a tapestry beyond comprehension. The sacred texts weren't wrong. They were working with the vocabulary of their time to describe truths we're only now beginning to measure. There's a thought experiment so chilling, it makes Schrödinger's cat look like child's play, a grim twist on quantum immortality called quantum suicide. Imagine strapping yourself into a chair with a gun pointed at your head, rigged to a device that measures the spin of a quantum particle. If the particle's spin points up, the gun fires. If it points down, the trigger jams. Now, here's where it gets harrowing. According to the many worlds interpretation, every time the trigger is pulled, reality splits. In one branch, you hear a deafening blast. In another, you hear nothing but the quiet click of a misfire. But here's the catch, your conscious experience can only continue in the timelines where the gun fails. No matter how improbable the odds, even if the gun fires 1,000 times in other universes, you'll always find yourself alive, staring at a weapon that seemingly refuses to work. This isn't just hypothetical macabre, it exposes the raw strangeness of quantum mechanics. Every time the trigger is pulled, the universe branches into two possibilities, one where you're gone, and another where you're left wondering why the gun keeps malfunctioning. From your perspective, you'd witness an impossible streak of luck, surviving against all mathematical probability. The longer the experiment runs, the more absurd your survival becomes, until the only logical conclusion is that your consciousness is somehow bound to the timelines where you persist. It's as if the multiverse is forcing you to confront the unsettling truth that death, from your own point of view, might be an illusion. Critics argue this is a reductio ad absurdum, exposing flaws in the many worlds interpretation. After all, if every improbable survival branches reality, why don't we see people miraculously walking away from plane crashes unscathed? Supporters counter that we do. Anomalous survival stories exist throughout history, like Vesna Vulovic, the flight attendant who fell 33,000 feet and lived. But quantum suicide takes it further, suggesting that for every miraculous survivor, there are unseen branches where they didn't make it. The survivor's consciousness simply follows the path where the dice kept rolling in their favor. The darkest implication isn't just about guns or gambles. It's about the nature of existence itself. If consciousness truly locks onto living timelines, then aging, disease, even the heat death of the universe might not be the end. There could always be a branch, however improbable, where life persists, forcing sentient beings into an endless dance with entropy. You might not live forever, but your subjective experience could never witness its own cessation. Some interpretations even suggest that near-death experiences, those bright lights and tunnel visions, are glimpses of the branches where your story continues, brushing against your awareness before reality resolves into the timeline where you wake up. Yet here's the cruel irony: even if quantum immortality is real, it doesn't grant invincibility. It just means there's no version of events where you experience your own death. The universe isn't protecting you, it's filtering your perception so you never see the end. And that raises a terrifying question. If the multiverse ensures you'll always find yourself alive, no matter how statistically improbable, then what happens when there are no more branches left to jump to? When every possible path leads to oblivion, that might be the one experiment even the multiverse can't run. Buried in the static of the cosmos, a faint afterglow from the birth of our universe, lies what might be the first tangible evidence of other realities brushing up against our own. The cosmic microwave background, or CMB, is often called the universe's baby picture, a snapshot of the first light to travel freely through space after the Big Bang. But this isn't just a relic of our past, it's a cosmic canvas, and some of its strangest brushstrokes, like the infamous cold spot, could be bruises left by collisions with other universes. Picture the CMB as the surface of a pond after a stone's been tossed in. The ripples you see aren't random, they're a record of every vibration, every disturbance in the water. Now imagine another stone dropped nearby, its ripples overlapping with yours. That's what cosmologists think might be happening on a universe-sized scale. The cold spot, a bizarre region of the CMB about 70 degrees colder than its surroundings, stretches nearly 2 billion light-years across. Statistically, it's an outlier so extreme that the odds of it forming naturally in our universe are less than 1 in 50. One explanation: it's the fingerprint of a parallel universe nudging ours during the chaotic infancy of the multiverse. When two bubble universes collide in the foam of eternal inflation, the energy from that impact would leave a distinct signature, a circular anomaly in the CMB's temperature map. The cold spot's shape and intensity match predictions for such an event, like a cosmic handprint pressed into the fabric of our reality. And here's the kicker: if this theory holds, that other universe might still be out there, hovering just beyond the edge of our observable cosmos, its gravity subtly warping our space from dimensions we can't perceive. But the cold spot isn't the only whisper from beyond. The CMB also shows eerie patterns of alignments, large-scale structures that seem to coordinate in ways standard physics can't explain. Some researchers argue these could be echoes of a pre-Big Bang universe, or even the gravitational echoes of a neighboring reality's black holes. Imagine dropping two tuning forks near each other. Even if you can't see the second one, you'll hear its vibration in the first. That's the tantalizing possibility here. The CMB might be ringing with harmonics from universes we'll never see directly. Of course, skeptics have alternatives. The cold spot could be a vast cosmic void, a region where matter is unusually sparse, stretching space and cooling light as it passes through. Or it might be a statistical fluke, a cosmic roll of the dice that just happened to land snake eyes. But here's where it gets compelling. When astronomers searched for such a void, they found one, but it's not nearly large or empty enough to explain the temperature drop. It's like finding a puddle when you expected an ocean. The most haunting implication isn't just that other universes exist, it's that they might be close enough to leave marks. If the cold spot is indeed a collision scar, then the multiverse isn't a distant abstraction. It's a bustling metropolis of realities, some brushing so close they leave dents in each other's spacetime. And if we're finding one scar, there are likely others hidden in the noise, waiting to be decoded. The CMB isn't just a relic of our origins, it's a message in a bottle washed ashore from the infinite ocean of the multiverse. And we're only just learning how to read it. Have you ever woken from a dream so vivid, so achingly real, that it lingered for days, not as a fading memory, but as a shadow of another life? What if those fleeting nighttime visions aren't just random neural fireworks, but fleeting glimpses through the multiverse's keyhole, where your consciousness briefly brushes against alternate versions of yourself living different stories? The ancient Greeks believed dreams were messages from the gods, but modern physics might offer an even wilder explanation. Dreams could be fragments of parallel existences bleeding through the barriers between worlds. Consider the eeriness of déjà vu, that spine-tingling sensation of reliving a moment you swear you've experienced before. Science tries to explain it as a neural misfire, where your brain mistakenly labels new input as memory. But what if it's the opposite? What if déjà vu is a fleeting overlap with a timeline where you did live that moment? Jung's collective unconscious, a shared reservoir of archetypes and memories, takes on new meaning in a multiverse context. Those recurring dream motifs, falling, flying, being chased, might not just be psychological symbols. They could be echoes of your other selves, reliving universal moments across the branching paths of existence. Think of your brain as a radio ordinarily tuned to one frequency, this reality, but during sleep, when conscious filters relax, maybe the dial drifts. Suddenly, you're picking up signals from stations normally out of range, stations broadcasting alternate lives. Ever dreamed of a place you've never been, only to visit it years later? Or met a stranger in your dreams who later appears in waking life? These aren't just coincidences. They might be proof that dreams are less about imagination and more about reception, that in the vulnerable, fluid state of sleep, the walls between realities grow thin. Quantum physics even provides a mechanism. In the many worlds interpretation, every decision point spawns new universes, each vibrating at their own unique frequency. Those frequencies could theoretically interact like overlapping waves in a pond. Dreams might be the ripples where those waves briefly crest together, letting you peer into the lives of other yous before the currents pull you apart again. And here's the most haunting part. If dreams are windows into alternate lives, then nightmares could be more than fears. They might be memories, that recurring dream where you're falling from a cliff. Somewhere in the multiverse, another version of you didn't wake up before hitting the ground. The shadowy figure chasing you through endless halls, perhaps a fragment of a timeline where the chase ended differently. Even love, those dreams of soulmates you've never met, might hint at lives where your paths crossed in ways this reality denied. This isn't just poetic speculation. Studies show that people report remarkably similar dreams across cultures, from flying to losing teeth to encountering deceased loved ones. If the multiverse is real, then these shared visions might be more than archetypes. They could be the collective subconscious brushing against universal truth. So the next time you close your eyes, remember, sleep isn't just rest. It's the multiverse's way of reminding you that every choice you didn't make, every path you didn't take, is still unfolding somewhere. And in the quiet hours of the night, you're given a front row seat to the lives you almost lived. If every possible version of reality exists somewhere in the multiverse, then somewhere out there, an Earth is burning. Somewhere, a civilization is crumbling under an asteroid strike we avoided. Somewhere, a version of you is trapped in a life of unimaginable suffering. This leads us to the most unsettling moral question the multiverse forces us to confront. If we know these realities exist, do we have an obligation to help? The film Everything Everywhere All at Once wrestled with this beautifully through its villain, Jobu Tupaki, a being who, upon gaining access to infinite realities, became overwhelmed by the sheer weight of existence. When every possible joy is counterbalanced by infinite suffering, what's the point of trying? The movie's answer, that love and kindness must be chosen despite the chaos, resonates deeply. But in a real multiverse, the stakes are even higher. Imagine discovering that in a neighboring reality, your counterpart is dying of a disease we've cured here. Do you owe them your research? If a parallel Earth faces climate collapse decades ahead of us, should we send warnings across the dimensional divide? Some philosophers argue that awareness creates responsibility. If we accept the many worlds interpretation, then every decision we don't make spawns universes where suffering unfolds unchecked. That knowledge alone might impose a moral burden not just to act, but to act in ways that minimize suffering across all branches. Others counter that without the ability to travel between worlds, such obligations are meaningless. You can't blame someone for failing to save lives they can't physically reach. Yet here's the chilling wrinkle. Quantum entanglement suggests particles can influence each other instantaneously across vast distances. If consciousness is similarly entangled, could our choices ripple outward, affecting probabilities in other realities? Studies on the placebo effect show belief alone can trigger measurable healing. What if that's not just biology, but a faint resonance with timelines where the treatment worked? If so, then ethical action in this world might subtly uplift others. The darkest implication, some suffering might be unavoidable. In an infinite multiverse, every tragedy occurs somewhere. No amount of intervention can erase that. But the same infinity guarantees universes where compassion triumphs, where help arrives in time. Our obligation, then, isn't to fix everything. It's to ensure this timeline leans toward light, because somewhere, the version of you making that choice is the only hope their world has left. For centuries, the multiverse existed only in thought experiments and philosophy books, but right now, in labs around the world, scientists are building machines to force parallel realities out of hiding. Take quantum duplication, one of the most mind-bending experiments ever conceived. Researchers at the University of Maryland have already trapped individual ions in superpositions where each atom exists in two places simultaneously, separated by distances larger than the atom itself. These aren't just fuzzy probability clouds, they're literal quantum doppelgangers, proof that a single particle can fully inhabit multiple locations at once. The next step, scaling this up to molecules, then viruses, then maybe even bacteria, creating living things that exist in two places at the same time. But the real game changer is brewing beneath the Franco-Swiss border. CERN, the same facility that discovered the Higgs boson, is now designing a successor to the Large Hadron Collider called the Future Circular Collider. This 52-mile underground ring won't just smash particles, it could smash realities. The plan: generate energies so extreme they create microscopic black holes. If Hawking's theories are correct, these black holes would evaporate instantly, but some models suggest they might briefly punch through to other universes, leaving behind telltale radiation patterns in the debris. It's like throwing a stone into a pond and watching for ripples from a second, invisible pond overlapping ours. Meanwhile, at Stanford, physicists are working on a different approach, a multiverse interferometer, that would exploit quantum entanglement to detect gravitational echoes from parallel worlds. Imagine two particles entangled so perfectly that any outside influence, even gravity from another universe, would nudge them out of sync. The setup resembles a cosmic version of those noise-canceling headphones that silence background hums. Only here, scientists are tuning out our universe's noise to listen for whispers from the next one over. And let's not forget the wildcard consciousness-based experiments. The University of London recently ran tests where meditators attempted to sense alternate versions of themselves making different choices. While still fringe, early results showed statistically significant correlations between brainwave patterns and quantum random number generators, as if the subjects were briefly syncing with timelines where their other selves took divergent paths. The most exciting part, these aren't pipe dreams. Quantum duplication is already reality. CERN designs are funded and underway. Every year, the boundary between science fiction and testable fact grows thinner. We're standing at the edge of a revolution, one where alternate universe stops being a plot device and starts appearing in peer-reviewed journals. The hunt for the multiverse has moved from chalkboards to particle accelerators, from philosophy to hard data. After centuries of speculation, science is finally catching up. From infinite doppelgangers to Boltzmann brains, from cosmic collisions in the CMB to dreams bleeding through from other timelines, we've journeyed through the multiverse's most shocking secrets, each one bending reality as we know it. But the true mind-blower isn't just that these possibilities exist, it's how they force us to rethink everything. Your choices aren't just yours, time isn't just an arrow. Even the laws of physics might be local customs in a vast cosmic metropolis. The multiverse doesn't just add new places, it rewrites the meaning of here and now. Think about it, every time you hesitated at a crossroads, another version of you charged ahead. Every fictional world you've ever loved, somewhere it's real. Every what if whispered at midnight is a documentary playing in another universe. And the wildest part, we might be brushing shoulders with these realities daily through déjà vu, glitches in the matrix, or even dreams that feel too vivid to be just imagination. The evidence isn't just in equations, it's in the eerie sense that reality isn't as solid as it pretends to be. So where does that leave us, not as small, insignificant specks, but as architects? Every decision spins off new worlds. Every observation might shape reality itself. The multiverse isn't just a theory. It's an invitation to marvel, to question, and to recognize that existence is stranger, richer, and far more interconnected than we ever dreamed. Now it's your turn. Which secret left you reeling? Was it the chilling Boltzmann brains, the universe-hopping UFOs, or the gut punch of quantum immortality? Drop your mind-blown moments below and keep looking beyond the curtain, because somewhere out there, another you is doing the same, and the conversation is just getting started.